we're doing enthalpy lab. It's a very easy and short lab. For that, we need to gather 2 test tubes. Again, everything is at the back. We can get those thermometers, or we can get our electronic thermometers. Make sure that if you use the electronic thermometer, you plug this into the LabQuest. All right? This is our thermometer. So for the first part, we're going to take a weight boat, put it on our balance, make sure that it's 0 with the weight boat on it, and we're going to use sodium acetate anhydrous. We're going to get between 1.20 and 1.25 grams of anhydrous sodium acetate on this. Please make sure that you write down every single number that comes from it. 1.2, 372. We write every single number that comes out of your balance. Once that we have done that, we try to transfer everything that is here to the test tube. Take a gallon cylinder. We add 10 milliliters of water to this gallon cylinder, and we transfer these 10 milliliters to the test tube. Really fast. You're going to check the temperature of the water before the addition of the salt and after the addition of the salt. The initial temperature of the water, you can check it anytime. The final temperature of the water will be once that the salt is completely dissolved. Once that we have done that, you record your room temperature, maybe 25 degrees. Your final temperature might go up, it might go down. The mass of water, because the density of water is, so the mass of water is going to be 10 grams, correct? So what you're going to do is calculate the delta T, which is going to be the final minus the initial. We're going to find the Q of this reaction, or the solution. It's going to be the mass of the solution, which is this plus this. The delta S is given, the specific heat capacity is given here. And the delta T you calculated. With that, you find the Q solution. And then you remember that Q solution is equal negative Q reaction. So you will have Q solution and Q reaction. That reaction is this. Sodium acetate in water dissociates to sodium plus and acetate ions. To find the delta H of this reaction, what we're going to do is the Q of that reaction divided by the moles. 1 moles. We have this mass in grams, and we're going to convert those grams to moles. And for that, we need to find the molar mass of sodium acetate. You will find the delta H of this reaction. That's the first question of your post-lab. First question of the post-lab part. The second part of the lab, we're going to use sodium acetate trihydrate. Make sure that you read the labels. For this, we repeat the process. We take a weighing boat, put it on our balance, make sure that it reads 0, add the salt to it until you record between 1.96 and 2.04. Again, record every single number that comes out of your balance, even if it's 0. Take a clean test tube, pass the salt to it, 10 milliliters of water, check the temperature at the beginning, check the temperature at the end, and once that you're done, you can dispose this in the sink. You have the mass of water again. It's going to be 10 grams. The mass of sodium acetate and trihydrate is important that you record this. The mass of the solution is going to be this plus that. Room temperature, final temperature, delta T, and specific heat capacity. The reaction will be the dissociation of sodium acetate trihydrate. The mass of the solution we know, the specific heat capacity we know, delta T we know, and we use the same formula. Q of the solution equals negative Q of the reaction. To find the delta H of this reaction, it will be the Q reaction divided by mole. But the molar mass that we're going to use now is the one that we used before plus 3 times. Plus 3 times the molar mass of water. No times 3, okay? Plus 3 times 18. Once that you have done that, you complete question 3. Move on to question 4 and 5 from your post lab, and we should be done. Thank you.